Hello and welcome to this lesson on rational numbers. Today we will learn about insertion of rational numbers between any two given rational numbers. Now you all know that there are infinite number of rational numbers between any two rational numbers. So your answers may vary depending upon the method you have used. So let's understand some of these methods of inserting rational numbers between any two given rational numbers through some examples. Let's begin. So here is our first question. Insert a rational number between 2 by 9 and 3 by 8 and arrange them in descending order. So we have to find one rational number between these two rational numbers and then represent them in the descending order, big to small. Now whenever you have to insert one rational number, we can use a very basic method which can be called the average or the mean method. So let's understand this method. Okay, so let's say if a is a rational number, 2 by 9 is a rational number, so let's assume that a is 2 by 9. So if a is a rational number and b is also a rational number, then in order to find a rational number between them, we can do the sum of the two rational number and then divide the whole expression by 2. So we will get a rational number exactly in between these two rational numbers. In the same way, we can also express this in this form: 1 by 2 times the sum of a and b. So if you add the two rational numbers and then multiply it by half, hold the same meaning as dividing the whole sum by 2. So either you can write the formula or the method in this form or this form, and you will get a rational number exactly between the two rational numbers. So let's apply this method. Solution. First, in order to keep it in the descending order, let's understand which rational number is bigger and which rational number is smaller. So we know the simple cross multiplication method. So you multiply the numerator of the first by the denominator of the second. So 8 into 2 will give you 16 and 3 into 9 will give you 27. So 16 is bigger or 27? Obviously 27. It means 3 by 8 is greater than 2 by 9. So we can express 3 by 8 is greater than 2 by 9. Now it is not necessary to express it in the descending order in the very beginning. At the end, after finding the rational number, you can express it. But let's begin with the descending order itself so that we don't have to do anything else after this. So to insert a rational number, we can apply this method. So 3 by 8 is greater than, so a rational number between them will be smaller than this but greater than this. So let's write it in this form. It will be more convenient. So we can write it as 1 by 2 half of the sum of the first and the second rational number that was given. So 3 by 8 plus 2 by 9. Now whatever we get here will be the rational number in between 3 by 8 and 2 by 9. So this will be greater than 2 by 9. So here we have 2 by 9. Now let's solve it. So 3 by 8 greater than 1 by 2. The LCM of 9 and 8, what can we have? 72, right? Then 8, how many times 72? 9 is 9 3 is 27, plus 9, how many times 72? 9 8 is so 8 2 is 16. 2 by 9. Let's solve this further. So 3 by 8 greater than 1 by 2. 27 plus 16 will give you 13 carry 1, that is equal to 43 by 72. Now we see we cannot cancel out anything. There is no common factor between the numerators and the denominators. So now we'll simply multiply. So 3 by 8, times 43 is 43 and 272 times 144 greater than 2 by 9. So here you see we have got a rational number by using the average or mean method between 3 by 8 and 2 by 9, and we have expressed them also in the descending order where this is big, small, smaller. So we can write this as your answer for the required question. Okay. Next question. Insert two rational numbers between -1 by 3 and -1 by 2 and arrange them in ascending order. So here we have to insert two rational numbers. Now for 2 or 3 rational numbers you can apply the same basic method which we did for the first question. So here, in order to arrange in ascending order, let's understand which one is smaller. So we can apply the cross multiplication. 2 into -1 will give you -2 and 3 into -1 will give you -3. Now if you see on the number line, -2 is greater than -3. -3 comes more on this side. So -3 will be smaller than this. So it means -1 by 2 is smaller than -1 by 3. So let's arrange it in the ascending order in the beginning itself. So we can say -1 by 2 is smaller than -1 by 3. Now let's use the same method to find two rational numbers between these two rational numbers. So in the next step, -1 by 2 less than, applying the formula, half and the sum of these two digits. So -1 by 2 plus -1 by 3 less than -1 by 3. Now for using this method we have to do it one at a time. Okay, so after we get this rational number, we will go for the next rational number between this and this, or this and this. So -1 by 2 less than 1 by 2, LCM of 2 and 3 will be 6. So 2 3s are 6. 3 into 1 -3 plus 3 2s are 6. 2 into -1 -2 less than -1 by 3. Let's solve further. So 1 by 2, now -3 and -2 will give you -5. So into -5 by 6 less than -1 by 3. Now here we cannot cancel out anything, so let's multiply. -1 by 2 less than 1 into -5, -5 by 2 6 are 12. So here we can conclude that this is one rational number between -1 by 2 and -1 by 3 in the ascending order. Now here they have asked for two rational numbers. So what you can do is you can apply the same formula to find a rational number between these two or these two. So let's find a rational number between these two in this case. -1 by 2 less than, to find a rational number, let's apply the formula 1 by 2 times 1 by -1 by 2, which is this rational number, and then plus this rational number, that is -5 by 12 less than, this is the next rational number, -5 by 12 less than, we have -1 by 3. So after solving this, we'll get another rational number between this and this, or we can say two rational numbers between this and this. So let's solve it. So -1 by 2 less than 1 by 2, then LCM of 2 and 12 will be 12. 2 6 are 12, so we'll get -6 plus 12 ones are, so 1 into negative 5 will get negative 5 less than negative 5 by 12 less than negative 1 by 3. Now let's continue it this side. Let's solve this one. So first let's write negative 1 by 2 less than 1 by 2 into negative 6 plus negative 5. So we have negative 11 by 12 less than negative 5 by 12, negative 5 by 12 less than negative 1 by 3. So let's simplify this. So negative 1 by 2 less than 1 into negative 11 by 2 into 12, 24 less than negative 5 by 12 less than negative 1 by 3. So we have successfully found two rational numbers using the basic method between these two given rational numbers and arrange them in ascending order. So if you want, you can emphasize more on this and write therefore two rational numbers between negative 1 by 2 and negative 1 by 3 are negative 11 by 24 and negative 5 by 12. Okay. Next question. Insert three rational numbers between 4 and 4.5. Now you know any kind of terminating or non-terminating recurring decimal is also a rational number. So here these two are rational numbers and we have to insert three rational numbers between them. Okay, so we can apply the same basic method till three rational numbers. Now if we think logically, between 4 and 4.5, if we consider 4 as 4.0 and this as 4.5, we can imagine some rational numbers between them like 4.1, 4.2, 4.3 and 4.4. So you can represent them also as the rational numbers between 4 and 4.5. But in this way, maybe your teacher will not give you marks. He might want you to do some hard work. So let's apply that basic method and get some rational numbers between 4 and 4.5. So let's represent them in the ascending order 4 and then 4.5. Now it is not compulsory if they are not asked to represent in ascending or descending order, it's not compulsory to use this sign. You can indicate a comma between these two as well. It's up to you. So even if you represent it like this, it's not wrong. So to get a rational number, we'll apply the same basic method. What is that? Sum of the first rational number plus the second rational number divided by 2. We were writing it in that form 1 by 2 into the sum because it was in the fraction form. Now here we don't have anything in the denominator, so we can just represent it as 4 plus 4.5, the whole expression divided by 2, which means the same thing like that basic method, less than 4.5. So if we add it up, 4 plus 4.5 will give you 8.5 by 2 less than 4.5. So 8.5 divided by 2 will give you 4.25, right, less than 4.5. Now let's find a rational number between these two and this two to get all the three rational numbers. So in one go we will get the other two rational numbers. So 4 plus 4.25 by 2 less than 4.25. So between this and this we got this rational number, less than, so another rational number between this and this, we will get 4.25 plus 4.5 divided by 2 less than 4.5. So between 4.25 and 4.5 also we'll get another rational number. So let's add them up. So 4 less than 4 plus this will give you 8.25 by 2 less than 4.25 less than 4.25 plus 4.5 will give you 8.75 by 2 less than 4.5. Now let's simplify this. 4 less than how much? 2 4s are 8.125 less than 4.25 less than 2 4s are 8, 2 3s are 6, 2 7s are 14, 2 5s are 10 less than 4.5. So the three rational numbers between 4 and 4.5 are 4.125, 4.25 and 4.375 using the basic method of finding the rational number. So you can write the statement. Therefore 4.125, 4.25 and 4.375 are the rational numbers between 4 and 4.5. Clear? Next question. Find 6 rational numbers between 3 and 4. Now, in this case, they are asking for 6 rational numbers. Now, up to 3 rational numbers, you can use that basic method of finding a rational number between two rational numbers. But when you have large number of rational numbers to be found, we use another method which will be more convenient. Okay. So, in this case, they are asking for 6 rational numbers between 3 and 4. So, let's begin. Solution. So, let's say the required number of rational numbers be n. So, n is equal to 6. Now, what we are going to do is we are going to add 1 to this required number of rational numbers. N plus 1, which will give you 6 plus 1, which is equal to 7. Now, using this 7, okay, we will multiply two rational numbers in such a way that the denominator becomes the same. So, here the rational number is 3. So, if there is nothing in the denominator of 3, we know it is 1. So, let's take this expression as 3 by 1. Now, let's multiply this 7 to the denominator to make it 7. When we multiply something to the denominator, we know that we have to multiply the same non-zero integer to the numerator. So, multiply the numerator as well by 7. So, the result will be 7 3s are 21, 7 1s are 7. So, we have got an equivalent fraction for 3, which is 21 by 7. And the other rational number is 4. So, 4 can be written as 4 by 1. So, let's change the denominator by multiplying 7. So, if you multiply something to the denominator, we multiply the same thing with the numerator. 7 4s are 28. 7 1s are 7. So, 4 can be represented as 28 by 7 into its equivalent form. Now, what this does is gives you ample room between the two rational numbers to imagine the rational numbers that can come in between them. So if we imagine something between 3 and 4, it will be a little difficult, okay? And then we'll have to think in terms of decimals. So in terms of the fractional form or the rational form, if we change it into this form by multiplying n plus 1 with the numerator and denominator, in such a way so that the denominator remains the same, we can imagine some rational numbers between them. So if you imagine, after 21 by 7, we can represent 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, 27 by 7 up to 28 by 7. So here we can say that 21 by 7 is less than 22 by 7, less than 23 by 7, less than 24 by 7, less than 25 by 7, less than 26 by 7, less than 27 by 7, less than 28 by 7. Now 21 by 7 is what? 3. 28 by 7 is what? 4. So in between that, you see, logically we have got 6 rational numbers. 1, 2, 3, 4, 5, 6. So here we did not have to do much. We just identified what can be the rational numbers in between them by multiplying n plus 1 with the numerator and denominator of both the rational numbers. So now what you can do is write, therefore the required rational numbers, or you can say the 6 rational numbers, required rational numbers between 3 and 4 are 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, 27 by 7. So these are the 6 rational numbers. Now you should keep in mind that a rational number should be in its simplest form. So there should not be any other factor which can divide the numerator and denominator. So change it into its simplest form. So here we can see we cannot change it or simplify it further. So we'll let it be as it is. And is what? 3. And 28 by 7 is 4. 21 by 7 is 3. 28 by 7 is 4. So you can go one more step after this, where you can represent 3 less than 22 by 7, less than 23, less than this till less than 4. So this is your required 6 rational numbers between 3 and 4. Okay. Next question. Find 5 rational numbers between 3 by 5 and 4 by 5. So it is like the previous question we did, where we had finding 6 rational number between 3 and 4. So there was nothing in the denominator then, so we had taken 1 in the denominator 1. This time it is given 5 and 5. So always keep in mind that the denominators should be the same. Means we have to represent them in terms of like fractions, if you remember the fraction chapter. So we can apply the same formula which we did for the previous question. So let's begin. Solution. N is equal to how many rational numbers? 5. So let's find n plus 1. N plus 1 will be equal to 5 plus 1, which is equal to 6. So we will multiply this 6 to the numerator as well as the denominator of both the rational numbers. So let's do it. So 3 by 5 into 6 into 6 will be equal to 18 and 30. So 18 by 30, and 4 by 5, then we can multiply 6 and 6 will get 24 and 30. So here you see you have got 18 by 30, the equivalent form of 3 by 5, and 24 by 30, equivalent form of 4 by 5. Now always remember that before you multiply n plus 1 to the numerator and denominator of both the fraction or both the rational numbers, make sure the denominators are same. If it is not given to be the same, find the LCM of the denominators and change it in terms of the LCM, so the denominator becomes the same, like the expression here, and then you multiply n plus 1 with the numerator and denominator. What will happen in such case? The result of the denominator will be the same. So here you see 30, here also we are 30, so it means they are part of the same like fraction. So now we can imagine rational numbers in between this rational number and this rational number. So how many we need? 5. So let's imagine all the rational numbers first and see what we get. So obviously if we present it in the ascending order, you know that 4 by 5 will be greater if you cross multiply. So less than, what will be after 18? 19. So 19 by 30.
Less than 20 by 30. Less than 21 by 30. Less than 22 by 30.
Less than 23 by 30. Less than 24 by 30. Now see, in this expression, some of the rational numbers can be simplified further. So let's do the simplification and represent them in the simplest form. So 18 by 30, the original form is 3 by 5. So you can write it as 3 by 5. Can we simplify this 19 by 30? No. So we leave it like this, 19 by 30. Less than 20. Here we can simplify this. We can get rid of the zeros, means divide by 10. So it will become 2 by 3. Then this one, can we divide by 3? Yes. 3 7 is 21, 3 10 is 30. So we can represent it as 7 by 10. Correct? Less than 22. We can divide by 2. 2 11s are 22 and 2 15s are 30. Then 23 by 30 we cannot simplify, so leave it as it is. And less than 24 by 30, which means 4 by 5. Correct? So we can say these are the 5 rational numbers now between 3 by 5 and 4 by 5. So we can say therefore 5 rational numbers between 3 by 5 and 4 by 5 are 19 by 30, 2 by 3, 7 by 10, 11 by 15 and 23 by 30. Easy? Last question for today's lesson. Find 10 rational numbers between negative 2 by 5 and 1 by 7. So here you see that there is a negative rational number and a positive rational number. So clearly we can understand that this is greater than this rational number. Now we have to find 10 rational numbers between them. So we can apply the same method where we consider, let's begin solution, where we consider n equals to 10. So what we do then? N plus 1, which is equal to 10 plus 1, which is equal to 11. Now sometimes if you take the same value n and multiply it with the numerator and denominator, having the denominator same, you might be able to find the rational numbers in between the two rational numbers. But it's better to be on the safer side and get more number of rational numbers in between rather than getting less number of rational numbers. So if you get 1 or 2 less, then again you will have to go for the process. So it's better you do n plus 1. That is the reason why we take n plus 1 to divide them into further parts so that we can identify more rational numbers between them. So here we see that this denominator is not the same. So in this case, we'll have to change the denominators and make them both in terms of like fractions. So how can we do that? By finding the LCM of the denominators. So the LCM of 5 and 7 is equal to 35. So we'll try to make the denominators equal to 35 first. Then we will multiply this n plus 1 with them. So let's write it down. So negative 2 by 5. What will be the number which we will multiply with 5 to make it 35? 5 into 7. So we can multiply 7 to the denominator. Now if you multiply something to the denominator, multiply the same to the numerator. The result will be negative 2 into 7, negative 14 by 35. And now let's look on the other side as well. 1 by 7. Now what can we multiply to 7 to make it 35? Obviously 5. So multiply 5 and the numerator as well with 5. So 5 ones are 5, 7 5s are 35. Now what do we see? We are getting negative 14 by 35 and 5 by 35. Denominators are same. And then we go on to the second step, which is multiplying n plus 1. But observe carefully, here already we have sufficient number of parts or rational numbers or some ample room in between them to insert rational numbers logically. So we don't need to multiply n plus 1. So these are the cases which you have to understand, where you don't have to multiply n plus 1 to get the required rational numbers between them. So here if you have negative 14, after that till positive 5 you have enough space. You can take negative 13, negative 12, negative 11, 10, negative 9, negative 8 and so on till 4. So we will not apply this step. We will not multiply n plus 1 with the numerator and denominator and further divide into smaller parts, otherwise we'll get lots of rational numbers. Here we have sufficient rational numbers. So let's represent them. So negative 14 by 35 less than, what can be the next rational number? Negative 13 by 35, negative 12 by 35 less than negative 11 by
35 less than negative 10 by 35 less than negative 9 by 35 less than negative 8 by 35 less than negative 7 by 35 less than negative 6 by 35 less than negative 5 by 35 less than negative 4 by 35 less than
negative 3 by 35 less than, we can continue here, negative 2 by 35 less than negative 1 by 35 less than 0 by 35 less than 1 by
35 less than 2 by 35 less than 3 by 35 less
than 4 by 35 less than 5 by 35. So here you see, logically we have already got so many rational numbers in between them that we don't need to multiply n plus 1. So from these rational number itself we will represent the 10 rational numbers. So it's up to you which rational numbers you want to select from these. Okay, so randomly you can select any rational numbers. It's better to leave one rational number in between. Let's count the total rational numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 rational numbers we got. So let's select some random rational numbers in between them. So let's select negative 13 by 35, negative 12 by 35. Let's leave 1 after this. Negative 10 by 35, negative 8 by 35, negative 6 by 35, negative 4 by 35. Then we can take negative 2 by 35, 0 by 35, 2 by 35, 4 by 35. Let's count to the extent 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so these are the rational numbers we'll select. Now see if they can be simplified further. Can we change them into the simplest form? For negative 14 by 35 is what? Negative 14 by 35 can be written as what? Negative 2 by 5. Then less than, we are taking negative 13 by 35. Okay. Less than, we are taking negative 12 by 35. Can we simplify this further? No. So leave it like this. Negative 12 by 35 less than negative 10 by 35. Now negative 10 by 35 can be changed into what? 5 2s are 10, 5 7s are 35. So we can write it as negative 2 by 7. Then we are taking negative 8 by less than negative 8 by 35. Cannot simplify, so leave it like this. Then we are taking negative 6 by 35. Can we simplify? No. So let it be like this. Less than negative 4 by 35 cannot be simplified, so leave it like this. Less than 2 by 30, negative 2 by 35, we cannot simplify, so leave it like this. 0 by 35. Now 0 by 35 means what? 0. So less than 0. Less than 2 by 35 cannot be simplified, so leave it like this. Then less than 4 by 35, cannot simplify 4 by 35, leave it. Less than 5 by 35, which means 1 by 7. So we have selected these rational numbers between negative 2 by 5 and 1 by 7. So it's up to you which rational numbers you want to select out of these rational numbers. You can select the first 10 as well after leaving the first one. Okay, so let's write it down. Therefore 10 rational numbers between negative 2 by 5 and 1 by 7 are, so let's start from here so that we can, okay, let's write it in the next line itself so we can fit in there. So negative 13 by 35 comma negative 12 by 35 comma negative 2 by 7 comma negative
8 by 35 comma negative 6 by 35 negative 4 by 35 negative 2 by 35 0 2 by
35 4 by 35 1 2 3 4 5 6 7 8 9 10. So this will be your answer. Clear? So that's all for today's lesson. I hope you understood. Please practice so that you get a better understanding. And if you have any doubts or queries, you can write it in the comment section. Till then, take care. Bye-bye.